Welcome to page 10 of your linear equations packet. Today we're going to be writing an equation for a table of values. We've written equations when we've been given a line on a coordinate plane, but this time we will not have an image. We will just have a table of values, and it's our job to write a linear equation. Remember, m represents the slope, the rise over run, or the delta y over delta x ratio, and the b represents the intercept, the y-intercept. Before we jump into the tables you see below, A, B, and C, let's take a quick look at a table. Let's take a look at this table of values. Pause the video and record this table in your notes. And when you're ready, turn the video back on. You can see that we've been given x and y coordinates. How are we going to write an equation for this table of values? We're curious, how does the x connect with the y? If x is your input value, how do we arrive at the output value? Well, we have a few tricks to take care of this. We're going to start by finding the slope. Delta y exists down the side of the y column, and delta x can be found along the x column. Let's check it out and see how our y's are changing. As we go from 1 to 4, we are increasing by 3. 4 to 7, we grow by 3, and 7 to 10, we grow by 3. If we look at our delta x column, we see each and every time we increase by 1. So, what is our delta y over delta x? We'll take this delta y and put it over this delta x. It's a positive 3 over a positive 1, which gives us a slope of 3. So, part of the mystery is solved. Our slope is 3 as we write this equation. But if you look closely, we've been given another wonderful clue. Right here at 0, 1, this is our y-intercept, the point where the line crosses the y-axis. So our b value is plus 1. That's how we output a y. 3 times x plus 1 equals y. Let's try it. Let's test this connection right here. Let's use an x value of 3. 3 times 3 plus 1. Do we arrive at 10? Well, 3 times 3 is 9. Plus 1 is clearly 10. That's the way we connect our x's to our y's. 3 times x plus 1 equals y. Now, we're not always going to be given the y-intercept in the table. We're going to have to dig a little bit. Let's go back to page 10. Take a look at the horizontal table given to us in letter A. Here, we're given a positive slope. Check it out. We know we have to write the equation mx plus b equals y. Let's start with our slope. We know we need to find our delta y over our delta x, our change in x. Well, in this case, x, which comes first and it always has, runs horizontally, and so do the y values. Let's start with our delta y, or our rise. As we look at the change that's occurring, we see that each and every time our delta y increases 9 to 12 by 3. So that's a positive 3. Our delta x grows by 1 each and every time. So delta y over delta x means that our slope, our m value, is 3. 3 times x blank blank equals y. We're going to leave a space for the y-intercept for a moment. If you scan the table, we don't have a y-intercept present. It's going to be up to us to do a little detective work to find that y-intercept. We're going to select an x and y coordinate and see how they connect. Let's see how 2 connects with 6, an x of 2 and a y of 6. Over here we write 3 times 2 blank blank. We need an output of 6. Well, 3 times 2 is 6. What would you have to add to 6 to arrive at an answer or an output of 6? Certainly 0. Let's test another connection. How about an x of 3 and a y of 9? 3 times an x of 3 blank blank equals 9. Well, again, 3 times 3 is 9. What would you have to not add to 9 to arrive at 9? 0. So clearly, this is our connection between x and y. Do we need the 0 there? No. You could just write 3 times x equals y. Now let's take a look at the next given table. In this case, we're going to discover that we have a negative slope. Next to the table, write delta y, and over here, delta x. Off to the side, write mx plus b equals y. Here we go. As we look at the pattern, we see that we're going from 11 and we're decreasing down to the value 5. That indicates a loss of 6, negative 6. From 5 to negative 1, that's a loss of 6, negative 6, and so on. Let's check out our delta x. As we go from negative 4 up to negative 1, we're increasing by 3. From negative 1 to positive 2, we increase by 3, and from 2 to 5, we increase by 3. So, what's our slope? Our delta y over delta x? A negative 6 over positive 3. Negative 6 divided by a positive 3 gives us a slope of negative 2. So far we know negative 2 times x blank blank equals y. Let's figure out what that intercept is. It's not given on the table. However, we can do a little detective work to figure that out. Let's try and make the connection between an x of 2 and a y of negative 1. Here we go. Negative 2 times an x of 2 blank blank, we need an output of negative 1. Well, if we multiply negative 2 and 2, we get a negative 4. What would you have to do to a negative 4 in order to arrive at an output of negative 1? Negative 4 plus 3. equals -1. So we believe our intercept is +3. You can test it again with one more pair. Let's try it. -2 times a +5, blank blank, we need an output of -7. -2 and -5 make -10. And if you think about it, if you add a +3, you will arrive at an output at -7. So our equation is -2 times x plus 3 equals y. Clearly we have a negative slope in -2, and our intercept is a +3. Now let's move on to our final table. It looks like for this particular table, there is no slope pattern present. But we have to look closely and work through the problem completely before we make that determination. Remember, your delta x lives here along the x column, and your delta y, your change in y, lives here along the y column. So our first job is to find the slope, our delta y over delta x. As we begin this process, let's start with the y's. To go from a -6 to a -2, we've increased by 4. To go from -2 to +8, we've increased by 10. And 8 to 10, we've increased by 2. And it seems as though there's no particular pattern present. Let's check out our delta x's. To go from a -2 up to 0, that's a gain of 2. 0 to 5, a gain of 5, and 5 to 6, only a gain of 1. Take, however, each delta y and put it over its delta x. 4 over 2, then 10 over 5, and finally 2 over 1. If we reduce each of these, we see we have a consistent slope of 2. So there is a slope when it sort of looked like we weren't going to get a consistent pattern. So our slope is 2 times x blank blank equals y. And if you look closely, you can see the y-intercept was given in this table. We see that our intercept is a -2. So here's our equation. 2 times x, x is what we're inputting, take away 2 equals y. Let's check this pair. We could have selected any pair, but 2 times an x of 6, well, this gives us 12. Take away 2. 12 take away 2 is indeed a y of 10. It checks out. Now complete page 11.